Welcome back. We have in previous videos understood what is the definition of logarithms. In this video, we will be talking about some common properties of logarithms. So let's talk about the first property. For log m to the base a plus log n to the base a is equals to log of m into n to the base a, where a is greater than 0, a is not equal to 1, and m and n is greater than 0, belonging to a real number. Let's prove this property, right? Let's prove this. So let's say x1 is equals to log m to the base a, and x2 is equals to log n to the base a, right? So m is equals to a raised to the power of x1 and n equals to a raised to the power of x2. Therefore, m into n is equals to a raised to the power of x1 into a raised to the power of x2, right? So therefore, m into n is equals to a raised to the power of x1 plus x2. This implies x1 plus x2 is equals to log mn to the base a, right? Property of this is how the definition of the log is. But if I substitute back x1 as log a to the base n and x2 as log n to the base a, then I get the property, right? So remember this: if you have sum of logs which has the same base, then you can write as one log property by converting the sum of the values m and n into a multiplication of these values, keeping the base same. So log m to the base a plus log n to the base a is equal to log of m multiplied by n to the base a. Great. We have seen the summation property. Let's talk about the subtraction. And if that is the case, what would be the guess of your answer? Yes, it would be log m divided by n to the base a. So how would you prove this? So let's again define what we started with. We said x1 is equals to log m to the base a implies m equals to a raised to x1. x2 is equals to log of n to the base a, which implies n is equals to a raised to power x2. What we are interested is in m by n. So m by n is equals to a raised to the power of x1 by a raised to the power of x2, which is equivalent to a raised to the power of x1 minus x2. Right? Simple algebra. So if I say log of, what does this mean? So log of m by n to the base a is equals to x1 minus x2, which is equals to log of n to the base a minus log of n to the base a. Right? So if you see this proves our property. So what are we saying? We're saying there is a subtraction of two log which has the same base, then we can represent it as the division of the values, right? So log m to the base a minus log n to the base a is a log of division of m by n to the base a. Great. Let's prove some more properties of logarithms. Those are two more intuitive properties where we talked about the subtraction and the division. Let's talk about another property, and it's a very important property which is used in many places when you will solving a different equation. So if you have a log of m to the power of x, then I can write this as a x multiplied by log of m to the base a. So we're saying if there's a power of the value, then we can bring x in front and we can solve this property as x times the value of the log. So how will you solve this? So again, let's say log m to the base a is p. What does that mean? This means m is equals to a raised to the power of p. So m raised to the power of x is equals to a raised to the power of p into x. Right? Now if I apply, so let's say this value is y, or what does this mean? Now I apply the property of log. So I'll say log, and I take this mx together and I bring a to the base is equals to p into x, right? Simply using the definition of the logarithm. So what does that mean? So log m a is equals to x times p. But what was p? P was nothing but log m to the base a. Right? This proves the property. What we are saying is, if there is a power to a certain number, and if we take a log of it, we can simply change it to a multiplication. So log a m to the base x is equals to x into log m to the base a. Now, why is this property so helpful? Suppose if you have to calculate 2 raised to the power of 1 by 99, right? To try to solve this, this is superbly tedious. But what if we say I need to solve log 2 raised to the power of 199 to some base, say 10. This is very simple. We can say 199 log 2 to the base a, right? And we can, so this is something which is solvable, and say suppose this comes out to be a certain number, let's say y. Then I can simply write 2 raised to the power of 199 is equals to a raised 10 raised to the power of y. Which potentially may be an easier calculation overall. So this property is something which should be remembered. So all of the three properties is something which is very, very useful. So let's again write those three properties. So what are these three properties? So there is the sum of the two values of log can be written as one log by taking the values inside the log into a multiplication. So log m to the base a plus log n to the base a is equal to log of m multiplied by n to the base a. Right? Similarly, when there is a subtraction, we can write it as m, instead of m multiplied by n, we say m divided by n to the base a. And if there is a power of the value, so log a m raised to the power of x, we can take x We can take it out as a multiplication value, and we can say that x into log of m to the base a. In all of these, we have assumed and what is true for the log, so that the log is feasible. Right? So we have assumed this so that we can always find the log of these values, that the log of these values are defined. Cool.